Hey there, in the last video we saw what variables are and some basic Matlab functions. Today we are going to see how we can take input from the user and display the output of a computation on the screen. We usually use either the disp function or the fprintf function to display output to the screen. The disp function is very easy to use but provides limited control of output formatting. The disp function displays exactly one value or variable to the screen. When you use disp function, Matlab displays the output command um, in the command window and then moves to the next line. So the disp function is particularly convenient for displaying vectors, matrices and complex numbers because it displays the entire array with a single function call. So here are some examples. Um, so with a disp function, you can print integers, you can print floating numbers, then you can display arrays, and you can display strings in the command window. Now you can create a single string from multiple strings and numbers using string concatenation. Concatenating means to link or to join. So here the Matlab function num to str will take a number, in this case pi, and convert it into a string. So when I run this, see, notice that the square brackets, these square brackets, they create this single string. So square brackets are required to concatenate strings. They tell Matlab to combine the strings or string representations of numbers inside them into a single string. Without these brackets, Matlab would treat each item as separate and wouldn't know to concatenate them. For example, in this case, we have three strings here. So this is one string. Now we convert the integer distance to string using the num2str function, then the third string. So this is how we concatenate strings and display them in Matlab. Now always remember to put strings in either inverted commas, single inverted commas or double inverted commas. Now we also have string cat function, strcat function in Matlab. It's used to concatenate strings horizontally. Now strcat, it can take multiple input arguments, which can be character arrays, cells, or character or string arrays, and concatenate them to form a new string data type. For example, in this case, here I have two individual strings s1 and s2, and using the string strcat function, I am concatenating s1 and s2, and here I have added a space between s1 and s2. Now let's look at the fprintf function. The fprintf function is a bit more complicated to use, but it allows you precise control over the format or over the output formatting. So how does it work? The fprintf function receives one or more arguments. The first argument must be a format string. A format string is a string with special codes called format specifier. Each specifier tells fprintf to plug in a value and how to style it. A format specifier begins with a % character and is followed by other characters that precisely describe how the corresponding output value will be formatted. A format specifier always contains a single letter, which is called format descriptor, that describes the data type of the output value. Now, the most commonly used format descriptors are %d, %e, %f, %g, %s, and %c. %d displays the value as an integer. Now %e display the value in exponential format. %f displays the value in floating point format. Now percentage %g, it displays the value showing only the most significant digits, and most of the time we use percentage %g while doing problems in Matlab. And here we have a percentage %s which displays the value as a string. You all know that string is nothing but a series of ASCII characters. So this returns a series of ASCII characters. Next, percentage %c is used to print a single ASCII character. In this case, the ASCII character B. So these were some commonly used format specifiers in Matlab. Now here you can see special escape sequences beginning with the backslash character. Now these are used to represent non-printable characters by the most commonly used escape sequences are \n and \t. Now \n, it gives a carriage return, means it starts a new line of output or ends the current line of output. It's like hitting enter button while typing. Now the main difference between fprintf and disp function is that this function moves to the next line after displaying a value or a variable, while fprintf, it stays in the same line after printing a value or variable. So we must always while working with fprintf, we must always put \n to move to the next line. Now a format specifier is described as like this. We first put a modifier, then the field precision, and at last the format descriptor. Now modifiers are special characters that control the formatting of an output. We usually have 3 modifiers: the plus sign, the minus sign, and the 0 sign. Now the plus sign left justifies the output in this field. So the plus sign ensures that a plus or minus sign is always printed with the output. The minus sign left justifies the output in the field. If there is no minus sign, then the output is right justified by default. Then we have 0. This modifier pads the field with leading zeros. Padding means it fills the empty spaces with zeros. Now field width is an integer that specifies how many spaces to use for the output value. If the field is too small, the fprintf function will expand the field to make it large enough to display the entire value. For example, in percentage %5d, the number 5 is the field width, which means the output will be a number of at least 5 digits wide. And next we have precision. Now precision only applies to floating point numbers. It specifies how many digits to display after the decimal point. For example, in percentage %0.2f, the number 2 is the precision, which means the output will be a floating point number rounded to 2 decimal places. Now here we have an example that uses these concepts. So when I run this, I get plus 0.123.46. Now the plus sign here, the plus modifier ensures that a plus sign is printed before the number. Now the 0 modifier pads the field with leading zeros. Now the field width here is 10. So the output will have 10 characters, and this 0 modifier will fill in the empty spaces with 0. So the next the precision is 2 here, so the output will be rounded off to 2 places. So we won't be seeing this. This will be rounded off to 123.456 will be rounded off to 123.47 46. So the output will be plus 0000123.46, which is a string of 10 characters with a plus sign, leading zeros and 2 decimal places. Now these were the different ways in which you could display the output in Matlab. Now a program may use the input function to get a value from the user. The argument of input function is a prompt string. This is called a prompt string. We enclose it within single inverted commas or double inverted commas. A prompt string is the text displayed to the user requesting input. So if I run this section here, see here you could see in the command window a prompt asking me to enter a number. So if I input 8, it gets stored in 8 in the variable 8 here in the workspace. Now by default the input function expects the user to enter a numeric value. So to get a string value, the input using the input function, you must include a second argument s in single or double inverted commas. So this is an example where we ask the user to input a string. So here when I run this section and type in my name, now my name gets stored here in the workspace in the variable name. So that was all in this video. We learned about disp function, fprintf function and input functions in Matlab today. Now in the next video we'll be looking at arrays and matrices. We will be learning how to manipulate arrays and matrices in Matlab. So thanks for watching. Bye.